Now we talk about power consumption in inductors and capacitors. So we will show that power consumption in both inductors and capacitors is 0. So first notice the formula for power. It is current times the voltage. So for inductors, you can see that the current we computed, so the current was minus Im cos of omega t, and the voltage was Vm sin of omega t. So notice that we are going to use the formula sin 2 theta is equal to 2 sin theta cos theta. So instead of theta you put omega t. So therefore you divide this by 2 and then you get minus Im Vm by 2 times sin of 2 omega t. So for capacitors, we found out that the current was, this was the current Im cos of omega t, and this part was the voltage Vm sin of omega t. Again you use the same formula here, divide by 2 and then you get sin of 2 omega t. So for average power, we know that the average power, if you want to compute, that would be nothing but 1 by t p dt, going from 0 to capital T. So average power you compute by seeing what power is consumed in small amount of time, and then you add all that power up and divide by total time t. So this time t we consider very large. So we want to integrate this expression now. So this part is just constant. So let us just focus on sin of 2 omega t. So notice that if you have the sin of 2 omega t, let us see the graph. So this is the graph of, say, sin of 2 theta. This is the graph of sin of 2 theta, and you can clearly see the average value is 0. So this is the average value. So you can see this in the graph that the average is 0. But let us do it analytically also. So if you compute the integral of 0 to t sin of 2 omega t dt, you will get 1 minus cos of 2 omega capital T divided by 2, and the cos is always less than equal to 1. So this is always less than equal to 1. So as t becomes larger, this entire expression goes to 0 as t goes to infinity. So we have been able to compute the average directly also as 0 as t goes to infinity. Now again, power average is, we have already said, this is nothing but 0 to capital T p dt, and then you divide this entire expression by t. So instead of p, we write down this formula Im Vm by 2 sin of 2 omega t. So this is our power. Here we are dividing by t by multiplying by 1 by t, and this portion will come out of the expression, and this will just reduce to, so power average will become this times 1 by t integral 0 to capital T sin of 2 omega t dt, and this is 0. So this we just computed. And so you can see the power consumed in inductors and capacitors is 0. And this is not the case for resistor. In resistor we had power consumption.